Have you ever wondered what it would be like to live on a planet where the day and night cycle is completely flipped? Imagine the sun rising in the west and setting in the east. Sounds like science fiction, right? But this isn't some wild theory, it's what happens on Mercury. The closest planet to the sun. Mercury doesn't just rotate like Earth and the other planets. It spins backwards compared to most planets in the solar system. But what does that even mean? And why is Mercury so different? Let's explore this fascinating truth. First, let's break it down. When we talk about a planet spinning, we're talking about its rotation on its axis. For most planets in our solar system, including Earth, the rotation is what we call prograde, meaning the planet spins in the same direction as it orbits the Sun, which for Earth is from west to east. But not Mercury. Mercury spins in the opposite direction. This is called retrograde rotation. This means that if you were standing on the surface of Mercury, which would be an interesting experience, to say the least, the sun would rise in the west and set in the east, completely opposite of what we're used to here on Earth. Now, this might sound like an unusual anomaly, but the question is, why does Mercury rotate backwards? To answer that, we need to dive into Mercury's weird and extreme characteristics. First off, Mercury is not like Earth in terms of its day and year. A day on Mercury, the time it takes to rotate once on its axis, is 58.6 Earth days long. That's already pretty strange, right? But here's where it gets even more mind-blowing. A year on Mercury, the time it takes to orbit the Sun, is only 88 Earth days. So Mercury's day is longer than its year. The strange dynamics of this relationship between the day and year are directly linked to why Mercury spins backwards. Mercury's orbit is highly elliptical, which means that it has a very oval-shaped path around the Sun. This elliptical orbit causes Mercury to experience an incredibly strong gravitational pull from the Sun. In fact, it's this very interaction between Mercury's elliptical orbit and the Sun's gravity that is responsible for its backward spin. As Mercury orbits the Sun, its gravitational field causes it to act a bit like a sloshing water bottle. It kind of gets pushed around in its orbit, slowing down and speeding up in unpredictable ways. This interaction has caused Mercury to rotate in such a strange, retrograde motion. But it gets even stranger. Despite this backward spin, Mercury's day, one full rotation on its axis, doesn't match up with its year. In fact, one day on Mercury is actually about 2/3 of its year. So, while Mercury takes 88 Earth days to orbit the Sun, it rotates on its axis about 2 times in that period. This results in Mercury having what is known as a resonant rotation, a unique dance between its spin and orbit. To add to the intrigue, it means that a single solar day, from one sunrise to the next, on Mercury lasts about 176 Earth days. Imagine what a day feels like when it stretches out for half a year. And don't think Mercury's backward spin just makes its days long. It also creates extreme temperature differences. The daytime temperature can reach a scorching 430 degrees Celsius (800 degrees Fahrenheit), while the nighttime temperature plummets to an almost unthinkable -180 degrees Celsius (290 degrees Fahrenheit). This temperature swing is partly due to the fact that Mercury doesn't have a significant atmosphere to trap heat, but it's also a result of its crazy rotation and orbit patterns. Its backward spin combined with its elliptical orbit means that the Sun's rays don't hit the surface consistently, which is why Mercury experiences such extreme temperature fluctuations. So, what does this all mean for Mercury's overall backwardness? Well, let's put it this way: Mercury's retrograde rotation is a cosmic quirk that challenges our understanding of how planets typically behave in the solar system. While Venus, the second planet from the Sun, also has a retrograde rotation, it's a whole different story. Venus spins in the opposite direction of its orbit, just like Mercury, but it also has a very slow rotation. A day on Venus lasts longer than its year. Unlike Mercury, though, Venus's rotation is due to its thick, toxic atmosphere and extreme pressure, which likely caused its strange spin in the first place. But back to Mercury. When you think about planets like Earth, Mars, and Jupiter, their prograde rotation makes perfect sense because they follow the typical pattern of rotating in the same direction as their orbits. But Mercury breaks the mold. Its retrograde spin is the result of a combination of factors: its proximity to the Sun, its gravitational interactions, and the mechanics of its highly elliptical orbit. These forces combined to create a backward spin that has puzzled scientists for years. In essence, it's like the Sun's gravity has given Mercury a gentle nudge, pushing it into this backward rotation. Now, as if this all weren't fascinating enough, let's think about the potential for life on Mercury. Because of its extreme temperature fluctuations, lack of atmosphere, and intense solar radiation, it's pretty clear that Mercury doesn't have the conditions needed to support life as we know it. But this backward spin and extreme environment offer scientists a chance to study a planet unlike any other. Researchers are able to gain insight into how planets interact with their stars and how gravitational forces shape planetary characteristics. The next time you look up at the night sky and see the shimmering dots of stars, keep in mind that Mercury, the smallest planet in the solar system, is also one of the most unique. Its backward spin, its extreme conditions, and its peculiar relationship between day and year make it a fascinating object of study for astronomers. While Earth and the other planets follow a predictable rhythm, Mercury dances to a completely different beat. And here's the crazy thing: the mystery behind Mercury's spin is still not fully understood. Sure, scientists have made huge strides in understanding why it rotates the way it does, but there's still so much we don't know about this little planet. Will new data from upcoming space missions reveal even more secrets? Will Mercury's backward spin continue to challenge our understanding of planetary behavior? Only time will tell. One thing's for sure, Mercury might be the smallest planet in the solar system, but it's definitely one of the most intriguing. And who knows? Maybe the key to unlocking even more cosmic mysteries lies in the strange motions of this tiny, backward-spinning world. So, what do you think? Could this backward spin hold more secrets than we realize? Or will we always be left wondering why Mercury decided to spin the way it does? Let us know in the comments. And if you found this fascinating, make sure to hit that like button and subscribe for more cosmic curiosities. The mysteries of space are far from over, and we'll be here exploring every last one with you. Keep looking up.